All right, your essential question for today is how do we graph and write equations of circles? So we're going to start off with a very, very simple shape, and these are all called conic shapes. And the first one is, there's four of them. The first one is we're going to do circles. So there's a couple of vocabulary words. In order to draw a circle, you have to know a couple of things. You have to know the center and the radius in order to graph and write the equation of circles. So those are the two things. We'll talk about a quiz later, but for right now, don't copy this slide down, but I just want to read through a couple of things with you just to refresh your memory over circles. So take a look at this slide, and it says, well, what's special about a circle? Well, let's start with this first question, guys. What do we call the middle of a circle? The center. That's right, yeah. So the center of that is right here. It's in the middle of that circle. The next question is, what is special about the distance from that center to any point on the circle? What's supposed to be special about all of those distances right there? They should all be the same, right? Because that's what makes a circle a circle. So the distance from the center point out to any endpoint on that circle, those distances are the same. It says, what do we call that segment that's from the center to the endpoint? Yeah, that's what we call our radius. And so it goes on to say down here, it says, what are the only two things that you need to know in order to draw a circle? Well, it's very quick. It's just you need to know the radius and the circle. That's right. If you know those two things, you don't need to write this down just to go back and refresh your memory. So those are the two things that we need to know in order to draw a circle or graph a circle or write the equation of a circle. Is the center, we know where the center is, and we know what the radius of that circle is also. If you know those two things, then you can draw the circle or graph a circle or write the equation of a circle. So here's the equation of a circle. What you do is, the center of your circle is written as the point HK. We don't like using the letters X and Y because we don't want to get them confused with the formula, and I'm going to give you that in a second. So the center, we label that HK. We let the letter R represent the radius. So the radius of my circle is written by the symbol R. The standard form equation, so this is what the part you do need to write down. This is what the standard form equation of a circle looks like. Two main things you notice is that it's equal to your radius squared, and if you notice that in parentheses, both of your terms are squared also. So this is what we call, when you have an equation that looks like this, that's what we call standard form. X minus h squared plus y minus k squared equals r squared. The reason why we like standard form is because if your equation is in standard form, you can easily look at it and you can tell two things. You can automatically tell what the center is, and you can also tell what the radius is. So that's why we like standard form. For example, let's say I had x plus 2 squared plus y plus 1 squared equals to 4. That is an equation that's in standard form. It's also a circle because I notice that both of my terms, the x and y, are squared, and it's equal to my radius squared. So if I can look at this, I can tell what my center is. The thing that you need to remember, though, is just like when we talked about graphs of trig functions, always think about the opposite inside the parentheses. So my center would not be positive 2, positive 1. What do you think my center would be, since you got to think opposite? Negative 2, right, opposite of positive 2. And then what do you think the other point would be? Negative 1. That would be my center. So always think opposite of what's in those parentheses. So that's x plus 2, y plus 1. Think opposite. So my center for this equation would be at negative 2, negative 1. The radius is always the square root of that last number, what it's equal to. So the radius of this circle would be the square root of 4. The radius would be 2. Which means if I were to graph this, I would go to the point negative 2, negative 1, put a point there. From that center, I would go up 2, down 2, left 2, right 2, in all directions, and then that would be how I'd graph my circle. But that's why we like standard form, is because you're easily able to just tell what the center and the radius are from that picture. So, case in point, if you take a look at these two examples, it says two ways to describe a graph. You can draw the graph, which is like here, and the first question says, well, what's the center? Can you look at this graph, guys, and tell me what the center is of this circle? Yeah, what's the center? Yeah, all right, it's 0, 0. Can you also look at this graph and tell me what the radius is? It's 4, yeah, that's right, yeah. And keep in mind the radius is always a positive number, but yeah, if you notice it's 4 in every direction, that's right. So I could give you a picture, but you can easily tell me the center and the radius. The question is, what if I don't give you a picture? What if I give you this function? Could you also tell me the center and the radius? Yeah, the center. Think opposite, though. What would the center be for this equation? -2, +3, that's right. And then what would be the radius? The square root of 9, which is 3. So just always remember, take the square root of that last number. That's perfect. And then you could graph it from there. All right, let's do a couple of them together. So it says identify the center and the radius for each of them, and then let's graph them. Let's just do them together. You don't need to write them down. Let's just do them together. All right, let's talk about the first one. What would the center of this top one be? What do y'all think? 3. Oh, shoot. Yeah, you're right. 3, -2. Can y'all see that? 3, -2. What's the radius, though? 2, right? Because the square root of 4 is 2. All right, what's the center of this circle? -4, -4. What's the radius? 10, okay? Be careful this one. There's no number with this x. What number represents nothing? No. What number represents nothing? There you go. So this is tricky, guys. The center for this one is technically at 0, 5. Because there's nothing. If you wanted to draw this out, you could put x plus 0 squared, right? But just notice there's no number there. So anyway, that's my center. What do you think the radius is for this circle? 7, that's right. All right, what's the center for? Yeah, 0, 0, sorry. 0, 0, and then what's the radius for this circle? 4, that's right, good. And then what's the center for this one? 11, 13, what's the radius? 5, perfect, that's great. So do you see why we like standard form? Standard form is easy to tell what the center and the radius are. Now, let's go backwards. Could you write the equation if I gave you the center and the radius? So let's do that together now. All right, so take a look at number 6. Let's do number 6 together. So notice I tell you the center is at 3, 4, but remember you got to think opposite. So what? Yeah, x minus 3 and y minus 4 squared. That's a key thing, guys. I heard y'all say squared. In order for it to be a circle, you have to square both of your terms. Finally, don't get tripped up. If the radius is 4, that doesn't mean this is going to be 4. It means it's going to be 16. Because remember, it's always the square root. So to go backwards, you square it. So that would be 16 for my equals 2 part. All right, the next one, same thing. It would be x minus 3 squared plus y minus 4 squared, but it would be equal to what for this one? 9, you're right. Now, don't be tripped up. It's a big number. But for this one, it would be x plus 2 squared and then y plus 2 squared. But can anybody think about what 25? Yeah, that's right. 625. That's big, but that's right. All right. Number 9, yeah. The center would be, so it would be x minus 5 squared plus y plus 6 squared, and then it would be equal to what, though? 1, okay, because 1 squared is 1. This is the one that probably would take a little bit of arithmetic. You get x plus 7 squared plus y minus 10 squared, and then, well, what the heck is 3 radical 2 squared going to give me? Well, what's 3 squared? 9. And what happens with the square and the square root? Cancel out, so that's just going to be 9 times 2, so what would that end up giving me? 18. And so that would be my answer for that one. So again, we love standard form because you can easily tell the center and the radius. The only problem, guys, is that not all equations are always going to be in standard form. Sometimes they're going to be in something that we call general form, which is not standard form. So let me show you what that looks like. So, for example, this is what general form looks like. The problem with it, though, guys, is if you notice, just by looking at it, do you think I'm going to be able to tell what the center or the radius are? Not by looking at it. So the first thing I'm going to do is, guys, if I have this in general form, if I want to know the center and the radius, I'm going to have to convert this. I'm going to have to convert this from general form. I'm going to have to convert that into standard form. And so that's what I'm going to have to do. That. So sometimes, guys, these equations aren't going to be in standard form. You're going to have to convert them first, and then you can do all the other stuff we've been doing. Now, the next thing I want you to notice, guys, is that I can tell that this is a circle because both of my terms, you see the x and the y, both of them are squared, and they both have the same understood coefficient. What was the understood coefficient for both of those? 1, right? So that's how I know that this is a circle and not anything else, because both of my x and y are squared, and they both have the same coefficient. All right, so what do we do? The problem is that if you don't have it in standard form, you can't just look at it and tell where the center and the radius are. That's the problem. So what we're going to do is we're going to convert these general forms into standard form. That way we can tell the center and the radius. So here is your first problem. It says x squared plus y squared plus 14x plus 6y plus 50. I know it looks really rough, but I'm going to do this first one together with y'all, and we'll practice one on our own. So this is not in standard form. This is what we call general form. But how do I know that this is a circle and not any other shape? Two things give it away. They're both squared, but what else? Both same coefficient of a 1. That's right. So here's what you need to do. I like to call this first step, I call it the group and move step. The group and move. What I mean by that is I'm going to group my x's together. So put x squared plus 14x and leave a space. Just trust me for right now. Leave a space. And then let's group our y's together. So you see I'm going to have y squared plus 6y and then leave a space. So you see how I grouped them, the x's together and the y's together? Sometimes you might not have to do that, but for this one I had to group them together. And then it says and move. Y'all see this positive 50? I'm going to move it out the way. But when I move it out the way, it's a positive 50. What's it become over there on the other side? Yes, so put equal to negative 50. That's right. So that's your first step, group and move. The second step is something that we talked about before. It's called completing the square. And it's a really simple process. The reason why I made y'all draw these blanks here is because we're going to fill these blanks in with numbers. Here's how we're going to get those numbers. What you do is you're going to take half of that number I just drew an arrow to, and then you're going to square that. So let's do it together. Half of 14 would be 7. 7 squared would be, so put plus 49 in that box. That's right. Now, here's the thing. In math, whatever you do to one side of the equation, you got to do to the other side. So put plus 49 over here. All right, going to do the same thing with the y. So draw a little arrow. Take half of 6, which would be 3. Square that, you get 9. But whatever you do on this side, you got to do on that side. And that's it. That's great. Now, the reason why we complete the square is because for step 3, we're going to rewrite it. And this is where we're going to get our standard form from. If you want to draw a little wavy line up underneath the x part, those first 3 terms, those are going to factor into a perfect square binomial. And see how it's almost looking like my circle now in standard form. The way we're going to figure out what goes into here, go back where you drew that arrow. What did y'all say half of positive 7 was? I'm sorry. What's half of positive 14? So that's what's going to go inside of here, x plus 7. And then plus, now draw a wavy line right here. All right, same thing. Set of parentheses squared. What did y'all say half of positive 6 was? That's what's going to go inside there. So you see where that comes from, x plus 7 squared plus y plus 3 squared. And then now you got to do your little arithmetic. Yeah, negative 50 plus 49 is negative 1 plus 9 is 8. That's right. And there it is. There's standard form. Now, could you tell me what the center of this circle is now? Yeah, negative 7, negative 3. But see, you couldn't tell me that before. So that's why you have to be able to convert it into standard form to be able to tell where the center is. That's right, and the radius. All right, take a second and try this one out. Okay? All right, so x squared plus y squared. Hopefully you wrote down the steps. If not, I'll write them down for you again right over here. So step 1, group and move. Step 2, complete your square. Step 3, rewrite. It's always going to be those 3 steps, always. It's in general form. All right, so the first thing is I'm going to group and move. So I'm going to group the x's together. So I'll have x squared minus 18x, and then just, well, I didn't stop. I know, because I didn't pause the video. I'll do the last one. All right, I'll do after this. So leave a space, and then group the y's. So you're going to get y squared minus 18y. Leave a space, and then move the 53, which is positive, move it over, so that's negative 53. Then you can complete the square. So I'm going to draw an arrow. Take half, and then square that number. So what will be half of negative 18? Negative 9. And then what will be negative 9 squared? Positive 81, right? Negative 9 times a negative 9 is positive 81. But make sure you put it over here also. So plus 81 over there. And then thankfully it's going to be the same thing for this one, right? Because half of negative 18 is 89. When you square that, you're going to get positive 81 again. So just put plus 81. And so now all you got to do is just rewrite it. So I'm just going to rewrite it with two sets of parentheses. So here's what I'm going to have. First set, half of negative 18 is negative 9. The second one, half of negative 18 again is negative 9. And then add them together, and over here you should get negative 15, yeah, 109. And that would be your answer for that one.